Salut.
Okay, so let's get started. Hi, everyone. Thanks for coming to the lecture. So this is the first lecture of the course Data Modeling and Databases. So what are we going to do today, right? So today we are going to kind of talk a little bit at a really high level because it's the first lecture about what we are going to deal with in this course over the whole semester, right? So we are going to talk about what is databases, right? So what is a database management system, and what do we even mean by data modeling, right? So we are not going to too theoretical on all these fronts because it's the first lecture, but we are going to try to convey to you why do they matter, right? Why should you care about them? and why should you hopefully be excited like about this course. So, and we are going to go a little bit, talk about a brief history about the evolution of database management system, right? So from the history and from like how people think about database over the years, we try to kind of abstract the good properties that we want from a database management system, right? So, and we are going to talk about why do we want them, right? And how can they help you? So for example, we are going to talk about all these properties like data independence, the database management system being declarative, right? So all those transactional access, generic abstractions that can be provided by a good database management system. And over this course, we are going to kind of go deeper into each of these different properties, and we try to understand how to use them to build a good application. And also later after Easter, we are going to talk about how does the database management system actually make it happen. And of course, because it's the first lecture, we are going to talk about logistics and also kind of general information about this course. So this is our goal for today. Okay, so in this course, in this semester, we are going to actually learn something pretty amazing together. And that's a database. It is actually pretty much powers essentially every single data intensive application that you are using today. May it be a website, may it be a mobile app on your phone, right? So all those large scale scientific endeavors, right, scientists are doing every single day. If you have an application that's data intensive, has a lot of data, right, highly likely there's some version of a database under the cover to support it. And now we live in a world where data is everywhere, and you can imagine how important database is as a very important component of computer system. So in this course, we are going to learn about two things. One thing is actually how to use a database. You have a whole bunch of data, right? So you put them into a database management system. How can you interact as a user with the database? How can you get the information that you want from a database system? And how can you design the schema of the database to support your application? And we are going to talk also on different aspect after you become a good user of a database. We are going to talk about how does the database management system make it happen, right? So we are going to try to open up a very simple database management system and see how it works, okay? So this course has two components, right? You are going to play essentially two different roles. You are going to become kind of essentially like a user of a database, but also kind of a developer of a database management system. And we are going to cover both. So database is really everywhere, okay? So let me just give you two examples, right? So here's Wikipedia, right? Everyone knows about this. And if you think about how does Wikipedia work, right? So under the cover, there's really a huge amount of data and information. And all those data and information are actually our knowledge about like this universe, right? So, and specifically, right, all those knowledge are organized as, for example, the content of each article, right? So the edit history of each article, right? And information about each contributor or each user, right? So all of this information are actually stored in your database system. And whenever you visit Wikipedia, so what's going to happen is that the Wikipedia website, right, the front end, is going to send a query to the database that contains all the information and select a subset of the information and present to you as a web page. So as of today, right, so there are 52 million pages or topics on Wikipedia. And if you compress them, that's roughly 20 gigabytes, right? But what the database is going to do is whenever you visit some web page, it's going to bring some of the information out of this 20 gigabyte of data and present to you in milliseconds. And as a user, you don't really need to care about how that happened. You can just enjoy that functionality provided by a database to you. And similarly, when you edit and contribute to Wikipedia, right? So you are going to save all those information into a database, right? And whenever someone else try to use this information, like try to visit Wikipedia, the system is going to bring that information from database to that user. And this is Flickr, right? That's another example, right? So essentially the information and data that we have here, right? So are all those photos, right? So all those users who submit all those photos, like also you have kind of text, like for each of this photo, and you have comments, right? So all of this, maybe not the photo itself, right? But all the other type of information are kind of stored in a system that's very similar to a database, right? So and when you visit a website, right, what's going to happen is very similar to Wikipedia, right? So the system going to actually query the database and give you kind of a subset of those information and show it to you as a web page. And also, if you kind of go on Flickr, you will realize, there's actually one recommendation engine, right? So like when you click a whole bunch of photos, the system going to recommend some new photos for you to look at, right? So if you think about how that happens, is the system have access to all those interactions that a user has with the system, right? And all of those interactions are kind of stored inside the database. And once in a while, the system going to try to extract insight from all those information and make some recommendation for you. Once you have all this data, right? So the system can present those information to you from a database, right? And also try to help you to get insight, to extract knowledge that doesn't really exist before, right? So these are just two examples about the role that a database could play, right? You can think about that as kind of a bridge between all the data that you have and also the application that you want to build. So essentially, in this course, we are going to talk about it as almost like a magic box, okay? That actually try to enable the following functionality. As a user, you submit a query to this magic box saying that, okay, I want this piece of data, right? So this is the property that I want, like in the result. And then this magic box is going to bring the piece of data that satisfies this condition to you. And as a user, you can do whatever you want on this result, right? You can do analytics, you can do machine learning, you can do data mining, you can do decision making, whatever, right? So, and this is the thing that we are going to talk about in this course. That is how to build essentially this intermediate layer between you as a user and the data stored somewhere in your computer. So, and we are going to call this magic box a database management system. Okay. So in this lecture, we are going to first talk about logistics and also the information, some general information about the course. And then we are going to look into kind of one real world applications about how data is playing a role and about how database is playing a role. Right? And the goal is really try to convince you, one, data is important, and second, a database system is important. Okay. And then we are going to go a little bit deeper to really try to understand what makes a good database management system. There are so many different ways you can measure data, right? What are the properties that we want from a database system? Now we are going to look at one very concrete examples and think about how the different ways we can make it happen. And then we are going to look at a brief history of database management systems. We are going to talk about different ways that people think about data model and try to compare them. So this is what we are going to do today. Okay, so let's start with logistics and general information, right? So you're all here, so I assume you received my email, right, about the Zoom link. All the information that you need are kind of available on this website, right? So essentially for every single lecture, if you click this, if you click here, you are going to see, for example, the slides for this lecture, the textbook chapters, right? Sometimes we have lecture note, sometimes we have kind of example implementation, right? So all the SQL queries, right? So all the information you need is here. And the format of this course is that we have lectures on Wednesday and Friday. In total, I think this semester we have 27 lectures. This semester, it will be online, at least before Easter, right, according to ETH regulation, right? So it will happen via Zoom, right? So, and Zoom link is on Moodle. Of course, we will record the lecture, right? So essentially, after every single lecture, I'm going to send out the link to the lecture, and then you can watch it. So we have the exercise session. Okay, so the first exercise is going to start in the 3rd week, right? So we are going to spend 2 weeks to actually learn a little bit about database, right? And then starting the 3rd week, we are going to have the exercise session. So it will be either Thursday or Friday, right? So we are going to partition the whole course, like all of you guys into 2 groups, partitioned by last name, and you are going to receive kind of the detailed information, maybe this week or next week from our TA. So exercises are not graded, right? But they are just there to help you to learn, right? Which is also very important. About the grading and the evaluation, like that we have one final exam, right? So that's like 100% of the grading. It will be online, and the exercise is actually very similar to the final exam in terms of both the platform and also the format. An exam will be very similar to last year's. We'll make them available, right? So it's very similar to previous exams in terms of difficulty, scope, and style, okay? And we are here really to try to help you to learn, right? So we have office hour, right? So essentially, after every single lecture, I will stay here, right, in this Zoom channel, and you can just ask your questions. If you need other time slot, kind of for me to answer your questions, just let me know. We can just schedule it in an ad hoc way. So we have a question and answering forum on Moodle, right? So if you have any question about the course, about the topic, right, you can actually just post on Moodle to ask your question, and our teaching assistant is going to answer them, okay? And if you have any other questions, feel free to send email to me or our teaching assistants, right? So if you kind of want to know a little bit beyond what we are teaching in this course, like database system in general or machine learning system in general, right? So also feel free to drop me an email and we can talk about research, right? And we really hope you to take kind of an active role like in this learning process. Okay, so just keep asking questions whenever something is not clear to you. Okay, so you can either type your question into the chat channel. Okay, so I may not be able to see it all the time, right? But I will at least try to answer them during the break. Okay, and also after each lecture or during the break, I will actually be here, right? So if you have any questions, just let me know. So last year we actually received a whole bunch of questions, and I'm really happy about it. So don't like feel free to ask whatever you want to ask, right? So for example, if you look at the recording from last year, right? So you can see some of the QA session last like the whole like full hour, right? So but I will be here. Whatever question you have, I'll be here to answer them. So don't be shy, just ask your questions, okay? So and also last year we have essentially 2 virtual office hour during the summer break. Essentially after kind of like this semester during the summer break when you are preparing for the exam, I had 2 virtual office hours, right? So very similar to the Zoom session, right? You guys can call in and ask me questions, right? So I think we are also going to do it this year, right? So that's another thing that we are trying to do to help you. And also if you have any feedbacks like about how you think we should run this course, right? Please let us know, okay? So this course is still, we are still in the process of trying to improve like how we teach database, right? And your feedback will actually matter, okay? If it's something easy to fix, we are going to fix it, right, this semester. Otherwise, we are going to integrate your feedback for the following years, okay? But give us feedback. So the structure of the course, right? So we have 27 lectures. So essentially, you can think about the course as essentially 2 different segments, okay? So in the first segment, we are going to teach you how to be a user of a database management system. You have one application you want to build. How can you use database to do it? And how can you model your data, okay? So the goal is really try to understand the basic database theory and being able to create, to query and use a database to build your applications, right? And also being able to model your application and design a database that actually makes sense, okay? So, and then we are going to switch gears and try to kind of look at what happened under the cover in a database management system. And there the goal is really kind of scratch the surface of a modern database system to really try to understand how does the database management system works, and also understand some advanced topics like transactions and recovery. Okay, so this is just to set the expectation of this course. This is actually kind of structure of these 27 lectures. Textbook. So we are going to use the book from Stanford, the English version, right? So if you want kind of a German reference, so here's like book in German. And if you are really interested in database and want to actually learn a little bit more than what we cover in this course, so there's a very interesting kind of theory book that you could read, right? But this kind of, but we are not going to rely on that one. Okay. So there's a whole bunch of online resources that we provide to hopefully kind of help you to learn, right? So, and database is a topic that kind of very mature, right? In the sense that people have been teaching that in almost all the universities, right? So, and there are a lot of great online resources that you can actually look at if you want to learn anything beyond this course, okay? So there's a great lecture series from CMU, from Berkeley, right, from Stanford, right? So, and you can actually watch them if you want, right? So if you look at kind of what we are trying to cover, right? So there's always two dimensions, right? One dimension is about how to use the database. Another dimension is actually how to build a database, right? So the system side, right? So we are kind of in the middle, okay? So we kind of try to teach you kind of both about how to be a good user and also how to be kind of a developer of a very simple database management system. Okay, so if you want to watch these online resources, right? So just keep this in mind. This is where we are. Okay. And also, if you want to learn anything, kind of go beyond this course, right? So kind of feel free to send me an email, and we can talk about it. Okay. So this is the logistics and general information about the course. Let me look at the chat channel and to answer those questions. Yeah, so just many messages. Let me read it through. Okay, so the first question. Do you have required readings? So I believe this is the first question, but let me know if otherwise. Okay, so essentially before every single lecture, I'm going to post on the website about essentially kind of the chapters of the textbook that we are going to deal with. It will be great if you can read them, but that's not mandatory, right? So it's always great to actually prepare like for the lectures, right? Like before you like attend it, right? But we don't have required readings, right? But of course, you need to read your textbook to prepare your exam, right? So, but we are not requiring any readings before the lecture. Okay. So another question is, can we switch group if we cannot attend the assigned group of exercise, right? Oh yes, of course, right? So just send an email to the TA and we can make that happen. Okay. Will the exercise session be recorded? Yes, yeah, they will be recorded and we'll make available to you. Will there be large differences between this course and the one last year? Well, the structure will be similar, right? But we are in the middle to actually keep improving this course, right? So yeah, you'll see some differences, but but I do not expect any significant change, right? Yeah, exercise session this week, we will not have that. The exercise session will start the third week. Yeah, so I'm about the assignment of the exercise session, right? So we will do our assignment, right? So like essentially, like the reason we want to do assignment is to make sure we have kind of a balanced distribution between two groups, right? So otherwise, and it's going to hurt your kind of learning experience, right? If one of the session is too large and one session is very small, right? So yeah, so let's solve that in an ad hoc way, right? So if you want to kind of select your group on My Studies, feel free to do so. We will try our best to respect it, right? But we cannot promise it, right? So in the worst case scenario, if everyone pick Friday, right? So we are going to like shuffle you guys, right? So but on our hand, like as long as the distribution is not off by too much, right? So we are going to respect kind of your choice, right, on My Studies, okay? So the book is additional relevant material, or will everything relevant for the exam be covered in the lecture? So I think the book is necessary in the sense that like in the lecture, we won't cover all the details that you need to know to prepare for your exam, right? So, but we try to give you kind of the high level kind of structure about how to think about the material, right? So after the lecture, I think you still need to read the textbook, right, to study it in order to prepare kind of your exam, right? We won't be able to cover all the details in the textbook. Okay. Okay, great. I think this is all the questions, right? So if you have any other questions, just let me know. Is it sufficient to read only the German book? I think so. Yeah. So like we had students do that in the previous semesters, and it turned out to be fun. Yeah. Okay, so I think that's all the questions. If you have any other question, let me know during the break or after kind of the lecture. Okay, so let's move on, right? So now let's talk a little bit about essentially data in real world, right? So here we are going to talk about essentially one specific applications that actually my group is building, right? And to really show you what's the role of data in real world applications, and also what's the role of database in real world applications. Okay, so and here, right? So when you kind of like look at this example, think about how our data used, right, to enable what we want to enable, and what type of data do we have, right? So what operations we need to do on the data, right? So like here, I will switch to one of my kind of like one researchers in my group who is kind of taking lead on this project, and he will tell you essentially these applications and also how that data is playing a role here. Yeah, let me switch to Leo.
Hello, everyone. Just the presentation, am I going to share it myself so that I can move through the slides? Question to Se.
Yeah, I think you are the co-host now. Right? You can share the screen. Right?
Okay, great. So give me a second. So can you see my screen?
Yes.
Great. Yeah, so thank you for your time, and thank you, Se, for inviting me. My name is Leonel Aguilar, and I am a postdoctoral researcher at SES Group. And I'm working on this project, which is digital support systems to improve child health and development in low income settings. So my intention with my brief intervention is first tell you very briefly about myself, give you an overview of this project, then talk about the data within this project, and finally have some thoughts and reflections about the machine learning and artificial intelligence on top of that data. So I want to emphasize that my expertise is not in databases. So please don't use this segment of of this lecture to base anything related to um, to the current coursework. So just for you to keep in mind, my work is mostly on high performance computing. I come from Guatemala, which is this little country in Central America, and last year I was named MIT Technology Review Innovator Under 35 for my work on evacuation simulation. And here you can see what this evacuation simulation looks like. We do massive simulations with millions of individual software agents, and and we do this at using this high performance computing infrastructure. So regarding the project itself of the digital healthcare intervention, if we look at the early childhood development, basically it is estimated that 30% of children under the age of 5 in low and middle income countries are stunned. That means that they will have a severe development impairments. So it is known that early life interventions are key for the general development. And we are talking about 250 million of children that we could improve their life through this kind of interventions. So what we are working on is in this personal caregiver support system. Basically is a chatbot that provides healthcare information or activities or articles to caregivers so that they can interact and stimulate kids. We are targeting right now the first 100 years of their life. And this is a project, it's a big consortium that is composed from the Swiss Tropical and Public Health Institute, ETH through CES Group, the Data Science Service and Systems group, a university in Peru called Cayetano Heredia University, Harvard University, and a startup called Afinidata. And basically, this chatbot has been developed by this startup Afinidata. And what we are going to be doing as part of this research project is improving this chatbot, this personal caregiver support service. And we are going to rigorously test on the Peruvian, on at a region of Peru. So we will be enrolling several families, and we will be measuring and these kids' development and providing them with this caregiver support. By caregiver, we refer to the father or the mother or whoever is taking care of the kid. So as of now, the service has provided around 2 million educational sessions from 2019 until now. So the service expects to have peaks of around 70,000 to 100,000 users during their peak times. Basically, whenever they broadcast a new content and they have many users flooding into the service to try to get this new content. And this is basically a sketch on how the service looks like. Basically, it is all running on a Kubernetes cluster. So here this rectangle is the Kubernetes cluster, and here are the caregivers interacting with the service. It could be through a specialized app, but currently we're using Facebook chat. We are connecting the chatbot to Facebook, and they communicate through this Facebook chat to the service. So there is a webhook, which is a service within the Affinidata ecosystem. Can you hear me?
Yes, we can hear you. Yeah.
Okay. Yeah. So this follows a microservice architecture where we have several individual smaller services, and they all interact through REST API. And some of these services have their own databases, and some of them have their own models. So for example, here we have the content recommender that has its own machine learning model in order to choose which content to serve to the caregiver. And for example, there is the content manager that needs to have a database to store the content itself. It could be articles, it could be healthcare advice, it could be sessions. And there are some services like the top-up service that doesn't require to save any kind of state. It's a stateless service. The traffic within the Kubernetes cluster is managed to Traffic, and the whole idea of this service is that, of course, the caregivers can interact with the service themselves, but there are also people that could be researchers or education experts that interact with the whole Affinidata service in order to provide content or monitor the state of the whole system. And that is a front end written in TypeScript. And it also interacts through the REST API with the Kubernetes cluster. This is just an overview of how the system is architecture and the technologies that are within this ecosystem. And regarding the data itself, the databases that are being used are relational databases. Throughout this course, I think you will learn more about all the concepts and all the theory and applications behind this kind of databases. We are currently using MariaDB in production, and the whole data model and database migrations are being handled through the Django framework. Here you can see a small snippet on how this data model looks like within the, um, the source code of one of the services in Afinidata. And yeah, so we can see many of the concepts that you will be seeing in this course, like the relationship between um, different fields in the data models, and um, but from the Afinidata perspective, all of this is being managed from or it's being handled through the framework itself and not through SQL commands directly to the database. And here we can see an diagram of the database of one of these services. Basically, we have many tables within each database of each of the individual microservices within the ecosystem. And um, of course, it's not as complicated as what you would be observing with real microservices such as Netflix, etc., where you would have um, thousands of microservices with many more databases and many and way more complicated um, relationships. But here you can see that even for a small program, it is already complicated, and we can see how some of the relationships between like articles and translated articles and articles interaction look like through this ER diagram. So related to the challenges itself from this from the data perspective, some of the challenges from the data management and data design side is the content duplication. So things that happen in these sort of ecosystems that are very young, like this Afinidata service, is that sometimes some of the content has been duplicated by two different services. They store one ID in one service in one way, and they store another ID in some other service with some other way. And how to deal with this content duplication is a real challenge. Also, the schema evolution, how the data looks like within each of the individual databases. That's a challenge, because the services themselves have been evolving over time. So what an article looks like and what an article should entail at the beginning is quite different to how it looks right now. And one of the bigger issues is how to keep consistency within all these individual databases. That is of course not just a challenge in this um, for this service, but it's a general challenge within the microservice architecture pattern. So some of the mitigation strategies that we have been brainstorming is to to capture the changes on each of the databases and then try to reconcile them or change completely the interaction pattern with the database. This is what this CQRS means, and that's from the design of the data and the data management perspective. But from the data quality, we have humans interacting with the system and providing either incomplete data, so they didn't finish the session and complete the certain data that we might need, or we have unengaged data where they say yes, 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 yes to all the questions, and we don't have any real signal from this data. And finally, from the machine learning and artificial intelligence opportunities within this ecosystem is that through the information that we gather from the caregivers and the babies, we could improve our curriculum recommendation. By curriculum, we mean the sequence of articles and the sequence of activities that we serve to the caregivers. And we could also improve the feedback or stimulate better feedback from the caregivers. And the features that we can use from this data for the machine learning or artificial intelligence side would be, for example, the baby characteristics, the age of the baby, so how many months old the baby is, the gender or the region in Peru or within a town within that region. We will have longitudinal developmental estimates. Basically, we would know how they have been progressing throughout time. We know the activities that have been served to the caregivers, and we are asking the caregivers for feedback on the effect of these activities on their kids. From the caregiver perspective, we have the interactions with the service, how often they were connecting and what kind of interactions they were having with the Afinidad service. How they are engaged with the platform, and the articles they have read and their feedback, and in general how much they like the service and the content that we have been serving. One of the opportunities that I see here is that this data itself has some structure and relationships that could be exploited for these machine learning and AI models. So that's all from me. And of course, you can contact me if you have any additional questions. And that's it for my intervention.
Thanks, Leo. Yeah, so let me share my screen. Yeah, so Leo will be here during the break. So if you have any question, I see there's some question in the chat window, right? So Leo will be here during the break and to answer your questions. Okay, yeah, so this is just one example about essentially how data and database could play a role enable some applications that hopefully can make the world a better place, right? So essentially after this course, right, so at the end of the semester, you should be able to build, and not the machine learning and the AI part, right, but essentially the cornerstone of the application that actually manage the data, that get you the data you need for downstream analytics, okay? So this is essentially like the thing that we are going to do like in this course, okay? So yeah, so now before we go for break, like just use 1 minute to actually give you kind of one definition of database, right? And then we are going to take a break and talk about it in the second half of the lecture, right? So essentially, as you can see from the example, right, what is database, right? Database is simply kind of a collection of data, right? For example, the information of your bank account, right? So data on Facebook, on Amazon, right? And database management system is actually a piece of software that is designed to assist in maintaining and utilizing kind of a large collection of data. You can query your data, you can update your data, right? So we hope to manage all your interaction with your data. Okay, so at this point, you may have some questions given this concept. For example, essentially, what is a database, right? It's a file or database, right? It's a file system or database management system, right? So I have C++ and Python. I have an array in my memory, right? So is that a database management system, right? Because a collection of data is a definition that's rather vague, right? So what do we even mean by that, right? So this is actually the question we are going to address in the second half of the lecture. We are going to look at one very specific examples and talk about all the good properties we want from a database system and try to distinguish that from a file system or from just an in-memory data structure you have in your program. Okay, so now let's take a break. I'll be here to answer your questions. And then we'll start our second half in 15 minutes. Okay.
So I guess I will answer some of the questions. I'm sorry if I said 100 years of their life. Yeah, it was 100 days of their life. Sorry for that. Yeah, the animals that were in the diagrams that I showed were basically the logos for each of the technologies. The whale is the logo of Docker, and the seal is the logo for MariaDB. And yeah, the hamster is the logo for Go, and it's because traffic is written in Go. And the reasons why microservices were chosen over monolithic architecture is first because of all these individual needs for having different compositions of the system for different interventions. So that's one of the reasons, and the other one is to improve the development the development phase, the development speed, so that teams can be working on smaller components of the app, just defining an API and then focusing on a specific microservice. And yes, it's basically more reliable and expandable. And thanks for your questions. So that's it from my side also. If you have any other question, you can contact me directly, or I will stay 5 more minutes here. Yeah, so regarding the the design of this database, it I, I was just showing how it currently looks like within the system. Um, there are definitely better ways of modeling and structuring the whole like all the data. So what happened there, what I imagine happened there, is that they were first envisioning the articles being only in one language, and then suddenly in one of the interventions that they are having, they had to quickly add another intervention or um, another language for the intervention. So that's kind of the dirty solution of just adding another table and linking this new table to the rest. But yeah, that's also why I was mentioning that this shouldn't be taken as some kind of ground truth for your course, but just how it looks in the wild, the design of these kind of systems. But yeah, maybe the best solution would have been to have only an additional field um, with the language code or something like that. Yeah, you're welcome. So if there is no other question, I would be leaving. But as I said, I would be happy to answer any question through email or I don't use Twitter that much, but you can tag me there or whatever. So it was a pleasure being here with you, and thanks a lot to Say.
Thank you, Leo. Yeah. Yeah, so we have one question. Are we going to notify you guys about what chapter we are going to cover before the lecture? Yes, so you can check the website. We will make that available before the lecture, yeah, about which chapter we are covering. Okay, so let's get started. Yeah, so in the first half of the lecture, right, so we talk about essentially why are data important, how they fit into a real world application, and how does database actually play a role, right? And we give you guys essentially one definition of database, which is simply a collection of data, right? And the database management system as a software kind of try to maintain and utilize a large collection of data. So now let's kind of dig deeper into that and try to understand essentially what do we want from a database management system? Why do we even need that, right? So why cannot we just store everything in a file system and just open the file whenever we need it, right? Why cannot we just put data in a main memory kind of data structure, right? And just write C++ code over that. So here we are going to look at essentially one specific application, and we actually use that as an example to get some feeling about why database is interesting and what property we want. So why don't we start essentially take this application, right? So and actually compare different ways of building it, right? So either with a database system or without database system. And we are going to compare them, and hopefully we can actually hopefully that can lead to a range of properties that we want in ideal database management systems. So why don't we start from the very beginning of database? This is actually kind of the first database system that people are building, right? This is the first application that people have for database. So I won't be able to play the video because I don't think you can actually hear the sound. But if you're interested, you can just watch this video. It's like kind of 5 minutes. So the very beginning, like around 1960s, right? So the first database system is actually built for the Apollo 11 project, which actually bring a human being to the moon, right? So if you think about why do we even need a database for that, right? So at the very beginning, people build database because they want to manage the bill of materials, okay? So because to build a rocket, right, there are so many different parts, and for each part, you have different suppliers and the cost and all those type of things, right? So this is huge amount of data, right? Even in today's standard, it's a huge amount of data, right? But in 1960s, I mean, it's pretty challenging. So and then people build the first database system to actually manage that, manage all those information. So here we are going to look at one toy scenario, okay? So this is a very simple kind of bill of material for one simple toy, okay? So you can think about what type of data do we have here, right? So we have a whole bunch of parts to build the real thing, the real toy, okay? And for every single part, what do we have, right? So we have their supplier, right? So, and we have a relationship between a supplier and a part, right? This supplier supplies that part, right? And for every single part, right, we have maybe some pictures, the cost, how many of them do we need, what's the name of the part, so on and so forth. So let's imagine this is the application that we want to build, and assuming this is kind of data we want to manage. If you have all this data, right, so there are a whole bunch of questions you might want to ask. There's a whole bunch of insight you want to get from the data, and we call them queries, right? So let's look at two example queries. One query would be, okay, so I have part A, find me all the suppliers that supply part A, okay? With this data, that could be one query you have. Query number two, I have supplier B, find for me all the parts that is supplied by the supplier, okay? So this is our setting. This is the data we have, and these are the two questions that we want to understand given this piece of data. So how would you build application like this, right? So, well, I mean, the naive way of doing that could be, okay, let's just write a Python script or C++ code or whatever, right? And try to manage this piece of data. So yeah, you first define essentially, okay, the data structure, okay? I have one in-memory array to store all the suppliers, all the parts, and which supplier supply which part, right? So, and I load data into this data structure, right? I add, for example, one supplier ABB, right? Into the supplier, I add maybe one part, the win, right? And then I kind of have some relationship between this, right? You know programming, right? So you know what we are doing. We define a data structure, and then we put data into those data structure, right? And then you can implement essentially these two queries, right? For the first query, right, find all the suppliers for part A, right? What would we do? Well, you can just enumerate all the suppliers relationship, right? And you can check the supplier and just give a supplier like a matrix what you want, I want to find. You just print out the corresponding data, right? You can implement query 2 in this way, right? So you can enumerate, right, all of the suppliers, right? So, and you just keep doing the checking. So this is just one very simple way that you could store your data in memory, right? And also query them. So you don't need to use a database for this, right? So, but what would be the problem if you manage your data in this way without a database system, right? Well, there are like a bunch of problems, right? The first one is, right, because your data is in the memory, right? Whenever you reboot your machine or whenever you kind of lose power, right, your data might be lost, right? Every single moment you restart a computer, right? So all those information and all the updates you have been doing over your in-memory data structure is going to be lost, right? And clearly for the application that we have in mind here to manage the bill of materials, that's not something that we want, right? And also, if you are building the application like a Facebook, like Flickr, right? You don't want all the information to get lost whenever your data center kind of get restarted, right? So your user will be very angry about that. So, and also it cannot handle the cases where the data is larger than the main memory, right? So even you have a memory, like a machine with like a 1 terabyte of memory, which is kind of like reasonable today, right? You can only store like 1 terabyte of data there, right? What if my data is way larger than that, right? How can I handle the cases where my information is way larger than the size of my memory, right? If you do a kind of application in this way, right? Just write some in-memory kind of data structure and populate it, right? So it's very hard to handle the cases where data is actually much larger. So, and there are a whole bunch of other problems, right? So for example, if you look at how we implement the second query, right? You can think about here, we actually have like a nested loop, right? Essentially we have 2 for loops, right? So how do you order them, right? So if you do kind of enumeration of supplier first, right? So all you can do the enumeration of supplies first, right? So you can change the order of the for loops. In real world application, right? Different way of designing that is going to have different performance, right? So which one is the best way like to do is actually depends on your data, depends on your application, right? So essentially, if you want to get the best performance out of the system, you kind of need to manually optimize how do you implement every single query. And especially when the data distribution keep changing, when the application keep evolving, that could get really out of hand, right? So that's also another thing that we actually do not want from the system. Okay, so this is just one way of building this application without a database, right? So, and we see a whole bunch of problems. So we can make this better, right? To fix some of the problems. For example, imagine we just change all those data structure into something not in memory, but we just memory map like to our hard drive, right? So does that fix our problem, right? So well, it's fixed some of the problem, right? So because now data is on disk, right? So to some extent, even if you lose power, right, some of the data will be there, right? So, but there are still problems, right? So for example, here, you kind of assume that you know how data are stored in your files, right? So for example, you are assuming, whenever I store a part, right? There's always, I store the ID of the part first, and then I store kind of the name of the part, right? So that's your assumption in the code. You are actually assuming you have information about the essentially the file structure, right? So I think about you have the application that keep evolving. For example, down the road, when you have more attributes for part, right? For example, now I want to store the color of a part, which was not in my previous design, right? So now it's going to change the data layout of the file, right? So you do not have any guarantee that the application you were building before still work in this new file format, right? So that could become a problem, especially when your application grow, keep getting larger and larger. And also there are problems about performance, right? So you all know that the hard drive is actually much slower than in memory, right? So the I/O is very slow, right? So, and essentially when you want to put all your data on hard drive, right? So you kind of want to optimize your algorithm, right? And as we are going to see in this whole course, that could be really complex. Okay, there are a whole bunch of optimization you need to do, right? So, and whenever you are building one application, you kind of need to redo that type of optimization for the application, right? Which is going to get really annoying and tedious, especially you are building those like large scale applications, right? Performance is a problem. So, and also again, right? So there are some problems that we saw in the first trial, right? The in-memory thing, right? So that still happen here, right? So for example, if you want to implement query 2, right? Yeah, you're coming to optimize it, right? So should I do like which for loop should I do first, right? So they all have a very significant implication on the performance or on the speed, right? So, and it would be great if we can have some system to manage that for us instead of every single time I build one application, I optimize it by myself, right? So, and also there are other things, right? What about concurrent access, right? So now all of the information on hard drive, what if, for example, 2 users just update the information at exactly the same time, right? So, and that could cause problems, as we will see down the road, essentially after Easter, we are going to see how that could cause huge problems, right? So, and how can you deal with crash, right? What if you are doing the updates and then someone put the plug of the machine, right? So you, like, how can you recover from the failure, right? When you are building large scale application, you have hundreds of machines, store all of your data, right? What if some of the machine fail, right? How can you do that? If we are building application without the database, just put everything in your file system, you as a developer need to handle all of these problems. And what makes things worse is whenever you are building a new application, you need to redo all of this for a new application because it have different data, have different data format, have different distribution of data, right? You need to redo all of this. And that could cause a problem, right? Because at least for me as a developer, I do not want to do that. I want some system to handle that for me, okay? So what we are going to learn in this course, that's a database management system, is a system that tries to solve all these problems that we see in these two kind of naive implementations. So once you finish this course, right, if you are going to build a view of measurement systems, what would you do, right? So you are going to actually use a database system, right, to hopefully get the following set of properties. What do we want? We want data independence, okay? So we want to make sure that the application do not need to know how data are stored, okay? Whether you are storing the ID of the part before the name of the part in your file, we don't want to know. We want to make sure the application will not change because you change the format of your file, or because you add a simple, add one additional attribute to part, to suppliers, right? So we want to make sure the application is kind of independent to the physical storage of your data, okay? So that's one thing that we want. On the performance side, we want to make sure your data access is kind of declarative, okay? Which means that the system should be able to store and retrieve data efficiently without you as a user worry about it too much. The thing we want is to say, okay, so this is the query I want to run over my data, but I do not want to optimize the execution and implementation by myself. We want a system to deal with that for us, okay? So, and we want some property about concurrent access and crash recovery, right? So we want a property like transactional access. So which means that even if there's multiple users interacting with my data, I want to make sure that the system has a behavior as if there's only a single user using the system. And we want to make sure if the system fails, right, we can still recover some of our data with certain guarantees. Okay, and we want to make sure we provide kind of a generic abstraction, which means that we don't want the user come to worry about all of the previous issues for every single new query they want to ask. We want to make sure whenever the user asks some query, all of these previous consideration, like data independence, declarative performance, transactional access, so on and so forth, are automatically conducted for that new query. So this is actually what we want from database management system, okay? So after this course, right, if you are building this application, so this is what you would do, right? So in the next couple of weeks, we are going to make sure you understand every single line of code on the right-hand side. But let's just look a little bit into the future and see what you would do after this course if you are building these applications, right? So again, you are going to have a declarative way of specify the schema, specify the shape or type of data you want to store in your database. And you have a declarative way to put information into the database, okay? And whenever you want to ask queries, right, instead of implementing the query all by yourself, you are going to have a declarative way of asking your query. For example, if you want to run query number 1, you are going to tell database, okay, so here's my query. I want to select this piece of information from these 2 tables with the following property. And database is going to automatically optimize the implementation of that and give you the data you want without you telling the database what to do, okay? So similarly for query number 2, right? So you are going to have this kind of high-level declarative way to tell the database what you want instead of how should database do it, okay? So this is what you are going to do after this course, right? So as you can see, this is actually reach the level of abstraction of how you as a user interact with your data. And that is what we want to enable. Okay, so let's look at all these properties, right? So data independence, right? So when you are asking the database, essentially like all those type of queries, you actually as a user do not know how the data are being stored, right? That's what we want to do. We want to enable efficient data access, right? So we want to make sure the whole thing is transactional, right? And we want to provide the generic abstraction. As you can see here, we are asking two different queries, right? But we are asking them in a very similar way, right? Okay, so now we talk about the great things that we want out of a database management system, right? So what could be the potential downside of using one, right? So yeah, there actually could be potential downside, right? So that's something you need to be really careful when you are using a database management system. One thing is about workload mismatch, okay? As you are going to see, every single database management system has assumption about how they model the data, okay? So for example, the database we are going to talk about, relational database, we actually model the data as a relation. You can think about them as tables, right? So if your workload doesn't fit into that, that could cause a problem, right? So that's something you need to be really careful about. And sometimes the workload will have mismatch, sometimes the data model will have some mismatch, okay? So that's why people have been focused on essentially different type of applications, different scenarios, and they kind of design different type of database management systems that form in this very crazy landscape, right? So essentially, whenever you are using a database management system, you want to think about your applications, think about your workload to make sure there's no mismatch, okay? So that could be a potential downside if you are using the wrong database management system for your application, okay? So now we talk about essentially the property that we want from a database. So now let's kind of go back and tell a little bit about the brief history of that. We are going to see essentially 3 different iterations of data model. And you can see kind of all those good properties that we have today, right? So we cannot take them for granted. At the very, very early days, when people are building database system, they are actually missing some of the properties, and that's actually causing problem over the years. So at the very, very beginning, okay, so there's the hierarchical model. And that's what the people have at the very beginning when they are building the database for Apollo 11. Okay, so the kind of the most famous system there is IBM IMS. So I think the first release is around 1968, and you are still kind of have a whole bunch of kind of queries running in MS even today. Okay, so and they are actually all over the place, right? So I think today there's actually like this system is almost half a century old, right? So but still there's kind of a 250 billion transactions probably every single day, like running this type of model. Okay, so how does it work? What are the advantages and what are limitations, right? So let's look at it. So how does IMS actually model your data? It's actually model your data in a very interesting way. So here's the data model. So it models the data and organize it as a whole bunch of record, okay? And it has different type of kind of record type. For example, you have supplier and you have part, right? So these are actually 2 record type. I have a whole bunch of records with the type supplier. I have a whole bunch of record with the type part, okay? And then there's an instance of each record type, right? For example, if you have the record type supplier, right? So one instance could say, ID equals 0, name equals ABB, country equals Switzerland, right? That's one instance of that type, okay? So, and you have database schema, which is a hierarchy of record types. So for example, this is one example of one schema. You say, okay, so I have 2 types. I have supplier, whole bunch of suppliers, and I have a whole bunch of parts, okay? And the hierarchy here is there's always a link from supplier to part, okay? So this is like one possible schema that you could have in IMS, okay? And database instance is pretty much a hierarchy of instances of each type. For example, this is one of the database instances that you could have. you can have one supplier, ABB, right, which is of the type supplier. And then this supplier kind of supplies part 1, supplies part 2, right? You could have another supplier, right, Swisscom, right? And you can have those hierarchical kind of structure between parts. You can have part 1, have 2 subparts, right? So this is your database. It's an instance of a whole bunch of record type. And then you have a hierarchy kind of like over all those instances. Okay, this is your data. So in IMS, this is how it models your data. So what if I want to kind of get insight from my data? I want to ask queries over my data. What would I do? So the query language, right, that IMS actually provides for you is actually very interesting. So it's record at a time. It's always return a record, and essentially give you a way to enumerate to like according to the hierarchical structure of the tree. Okay. So this is actually, you can actually like use that today, right? So like essentially this is the abstraction it's trying to provide. It starts from the root of the tree of the hierarchy, and then you say, okay, I can get the next record, right? Either my child, right? So or my siblings, right? So it gives you all those kind of ways for you to kind of like traverse the tree. Okay, so this is actually the query language that IMS provide. So for example, if I want to find, for example, all the red parts supplied by supplier B, what would I do, right? So you would just write something like this. You first say, okay, so first find me all the supplier with certain name, okay? So that's going to bring you to one specific node in the tree. For example, here, ABB, okay? So after you run the first line, you are going to be here in the tree, okay? And then you just get next within parent, which means that I go to all the child node, part 1, and then I do something with it. I check whether the color is right? So if it's right, I do something. Otherwise, I move on to the second child, like under this parent node. So this is actually how you would implement the query within IMS. Okay. So and what if? Yeah. So like this actually, like you run it, this is actually what would happen, right? So, and the second thing, like what if you want to say, okay, give me all the supplier for part A, right? So this is actually going to become very difficult, right, in IMS, simply because when I actually enumerate the record, I need to follow the hierarchical structure. It's very hard for me to actually find a part and go back to the parent. So this is actually one thing that becomes interesting. You're going to see as a limitation here is because we are enforcing certain notion of how the data is organized in IMS. When you query it, different type of queries might be kind of difficult to to implement, right? So if your query actually fit into your data structure, it's very easy to implement as the Q2 here. But if some of the query doesn't fit your data structure, it could be very, very difficult for you to implement that. And that's actually one example here. Okay, so what if I really want to answer Q2? Sorry. So what if I really want to answer Q1? Right. So actually, the most natural way is for you to reorganize your data. Right. You have the part first, and then you'll have the supplier as a child instead of the other way around. Right. In that way, you can actually kind of implement the Q1 in a very natural way. But on the other hand, implementing Q2 could be very hard. Okay. So this is actually one limitation that the IMS has, right? Those hierarchical model has. That is, it kind of coupled together the query language and your data. Okay. So, and essentially, whenever you are writing the query, you assume the developer knows how the data are organized. And this actually causes problems, as you can see. And that is actually something we do not want in a modern database system. And I mean, at least for those relational type of database system. Okay. Yeah, so let's look at limitation, right, of the hierarchical model, right? So let's just revisit all those properties we want. Data independence. We don't really have that, right? Because here we are actually assuming my data is a tree, right? So they actually organize in a way that's predefined, right? So whenever I'm building an application, right, so I need to use that piece of information, right? And second, when there's a mismatch between the data, right? So and your data model, for example, your data is not a tree, right? And you are going to have a whole bunch of redundant information, right? For example, if both ABB and Swisscom provide part 1, right? So if you are forcing the database to actually store it as a tree, right? So you are going to have kind of duplicate like information of part 1, right? So, and also this type of redundancy is not only about space, right? But there is also the root cause of inconsistency. Okay, think about someone just update the part 1 here, right? And some other people update this part 1, right? They will have inconsistent kind of like type of information. Okay. So yeah, and also another thing about data independence is when you write a query, whether the query is going to change if you change the data layout, right? So here, yeah, it's going to change, right? So assuming my data is stored in this way in schema 1, right? So if I want to answer query 2, I can write something like this, right? But what if I kind of change my data layout in the future? Yeah, you cannot run this query anymore, right? Your application is kind of coupled together with your data layout and this your data schema, right? So, and that's actually something that we do not want, okay? So, and whether we have declarative efficient data access, right? It's not really, right? So, because to answer one query, right? For example, if my data schema looks like this, I want to answer query 2, right? So there are different ways for me to implement that, right? So, if you give me a different database instance, maybe one implementation is better than the other, okay? So as a user of the system, right? So I really need to do manual optimizations for every single database and for every single implementation of the query that I want to do, okay? So, and also this is also not something that we want from a database system, okay? So let's recap, right? So the very, very beginning, you have the hierarchical model, right? In the data model, you have a whole bunch of record type, you have instance, right? A database is simply a hierarchy of the instances. So the query language that you have is a record at a time. Yeah, essentially you traverse the tree, right? So, and there's a whole bunch of problems if you take this view, right? First one, a hierarchical model might be too restrictive for many of the applications, right? If you have application that's doesn't fit like into a hierarchy, right? So you might have a whole bunch of problems such as data redundancy, right? It doesn't give you kind of data independence, okay? So I mean, you need to change your application, change your implementation whenever the physical data representation changes, okay? So, and it's require manual query optimizations for different data distribution, for different kind of data layout, right? So, and of course, there are applications in which all of the previous problems are not problems, okay? And that is why IMS is still being used today in many applications, okay? But for many applications, all of this will become a problem. And that's what people realize kind of almost half a century ago, right? So the next question is actually, can we do better, right? Now we have the hierarchical model. Can we do better? So this is actually another data model people have been working on over the years, and that's called the network model. So it's actually, it started kind of in 1969, right? So, and first integrated into COBOL, right? So let's look at how does it work, right? So what are the advantages and what are the limitations, right? So it's actually interesting. So the data model here is actually, I still have my record type, okay? My supplier, my part, they are record type. And I have instances, right? So very similar to the hierarchical model, right? So for different record type, I have different concrete instances of that type. So when you define a database schema, in network model, it's not a tree anymore. It's not a hierarchy anymore. It is actually a network. Okay, it's a network of record types of instances. Okay, for example, this is actually one schema that I could define in a network model. Okay, so I have 3 record types. I have supplier, I have parts, I have supply. Okay, and then there's a relationship between these record types. For example, supplier supplies like participate in the supplies part of the supply relationship, right? So and the part like also participates here. Okay, you can think about this like as a network over record types. So and whenever I have a database, right? So it's become a network of all those instances. For example, I have a supplier ABB, right? So I have part one, they participate in supply one, right? So, and then I could have a network like this. So this is my database. And for the query language, it's also very similar to the hierarchical model. It is record at a time, and essentially give you a way for you to traverse the network. For example, if you want to implement this query, right, give me all the red parts supplied by one supplier. So what you could do is say, okay, so first find me one supplier, which is here, right? And then I just enumerate like all the like relevant record, right, connected to the supplier. I come from ABB, I enumerate to supply one, and go and then for supply one, I find the part, okay? And also for ABB, I go to supply three, and for supply three, I find part two, so on and so forth, okay? It gives you a way for you to actually enumerate the record in this network, okay? And similarly, if you want to do query one, give me all the supplier for part A, right? So what you would do is you first find the part, okay? And then you enumerate all the supply kind of instance, and you go back to find the supplier, okay? As you can see, it's much more flexible compared with the hierarchical model, okay? And also more powerful. So both of these queries are natural. It's definitely improvement, okay? So compare with what we have in the hierarchical model. So this is what we have, right? So let's kind of go back to all the properties that we want out of a database and to see whether there are problems or not. So in terms of data independence, right? So as you can see, we have the same problem, right? So data model is definitely much more kind of flexible, but still problems. Whenever I'm writing my query, I kind of assume that I know how data are organized, right? So if you change how the data are organized under the cover, I cannot need to rewrite my high-level queries, right? It's not data independent. I'm just not something I want in many of the applications. So whether it's declarative, well, not really, right? So the same problem can can still happen, right? For every single query, there are different ways that you can actually implement that. Which one is the best? We don't know. It depends on the data distribution, depends on application, right? So there's no way the system can actually optimize that automatically for you, right? It's not really declarative. So just to recap, right? So the network model, right? You have record type is pretty much a network between record types, right? So query language is a record at a time. It still have a whole bunch of problems, right? So can we do better, right? And that's actually bringing us to the focus of this course, that is relational model. So at a very high level, right? So what's relational model, right? So it's actually started around the same time, around 1970, something like that, right? So it's the first kind of proposed by a really fundamental seminal paper, right? So it's one of the most popular today, and also the focus of this course. So again, let's try to revisit the three different questions. How does it work? What are the advantages? And what are the limitations? So the data model of relational model is interesting. So instead of model the database as a network or as a hierarchical instances, in relational model, we model the data as a set of relations. And each relation is a set of tuples of the same type. It's very similar to record type that we see in hierarchical model or in network model, okay? So instead of having all of this, we just model everything as a set of record, okay, without their kind of, without links between them, okay? And the instance of the database, you have instance of each relation, right? Each relation contains a whole bunch of instances, right? For example, you have supplier relation, you can have a whole bunch of tuples. This is one example, right? Like in that relation. And the database schema is a set of relations, right? Database instance is a set of instances for each relation, okay? So that's pretty much what you have. You can think about the database now as a table, okay? I have a table of all the suppliers, I have a table of all the parts, and I have a table for all the supply relationship between the supplier and the part. Okay, so this is actually what database looks like if you are doing a relational model. And if you want to query it, want to get insight out of your data, the query language that we are providing is actually fundamentally different. Instead of doing those record at a time type of query language, we now have a set at a time. Essentially, we are going to think about every single table as a set of record, and we are going to use set theory to actually manipulate those operations. For example, if you want to find all the supplier for part A, instead of tell the system what you want to, like, listen, how to implement that, how to find that record, you are going to actually give the system something at a little bit higher level. Okay, you are going to say, okay, so what I really want is for you to select information from these two relations with this property. And I want you to project all the information you have into the supplier ID and also supplier name. This is actually a fundamental difference between relational model and network model. So as you can see here, we are actually give you the declarative kind of definition of the data I want, instead of tell the database how to find that. Okay, so that's the difference. And we are going to go really deep into this in the next couple of the lectures. Okay, so similarly, if you want to find write a different query, right? So you can actually use the same principle, right, to specify the property of the data you want, instead of tell the database how to find it for you. So the consequence of that is, because we are actually model the data not as a network, not a hierarchy, but as a set, you actually have no idea how the data are stored and represented. Because in your data model, you are not assume any order of different instances. They are set. They are a set or bag of examples, right? I don't know their order, and when I query it, I cannot use their order. And that is why it's going to become data independence, right? Because even if I just reshuffle how the data are stored within a single relation, your query doesn't need to change, because when you write the query, you are not using that piece of information. Okay, and it's going to be kind of declarative in the sense that I specify at a really high level the properties of the data I want, and the system is going to try to automatically find an efficient way to implement that for you. Okay, so that's what we want to achieve, and that is actually why that could be enabled by relational model. But on the other hand, it's also make it much more difficult to build such a system, right? So that we are going to talk about in this course. So there's a great debate actually around 1974, right? Like about which one is actually better, right? Relational model, network model, which one is better? So today, if you look back, right? So the answer could be pretty natural, right? For the application that we want to do, and if you really cares about all those properties, clearly relational model is actually better, but it wasn't that clear back in 1974. There's actually a pretty intense debate back then about these two different ways of model your data. Okay, so at the end of the day, right, both of the data model, they actually improve a lot, right? The network model actually integrate a whole bunch of things from the relational model, and relational model actually getting better in actually optimize the implementation for you, right? So at the end of the day, both of the two sides improve a lot over time, and the market actually, for the application that we cares about, choose relational model, right, at the end. Yeah, so just to recap, right, we kind of go through a little bit of history of data modeling, right? So we see three different data models: hierarchical model, network model, relational model. They have very different flavor. Two of them, kind of hierarchical model and network model, they are imperative. To query the data, you need to know how data are organized, and you need to tell the database how to find the record you want. Right? And there's one data model, the relational model, that's kind of declarative. Right? You have no idea how the data are organized physically. Whenever you want to query the data, you kind of give the system something declarative. You define the property you want of the result, instead of telling the database how to get it. So with the importance of data independence and the declarative performance optimization, right? So, and also, yeah, design data model and query language are not trivial, and we are going to talk about that during the course. And because we are talking about history, right? So let's talk about what's next after relational model, right? So the hierarchical model actually still exists. I mean, you trigger a lot of queries today. Essentially, whenever you go to the bank, right? So highly likely you are actually querying some hierarchical database. So the network model also kind of exists, right? So if you look at XML and JSON, right, you can actually see the similarity between XML and the network model. Okay, so they are still very, very important. So and database management system today is actually a huge industry. Okay, it's very, very, very exciting. So you can see different data models. You can see databases just to store different objects, right? So store the graph, store documents, right? Store matrices and array, right? Key value store, right? So all of them have different assumption on what is the database and what is your data. Because of their different assumption on the data model, you get different database management system. And you can see a whole bunch of query languages. You can do analytics, there's data cube, there's machine learning, all of them, right, being mixed together into the things that you can do over your data, okay? And then you see database with a whole bunch of new technologies. You have those databases being accelerated with new hardware like LPGA, right? Like auto GPU type of thing, right? And you can see the database being kind of optimized, for example, by machine learning, right? So how can I learn how to run the algorithm over my data, right? How can you automatically tune a database, right? So if you look at the database like as a kind of academic scientific topic today, right? It's a very diverse kind of community dealing with different data models, different ways of query your data, and different ways of making the query better. Okay, so in this course, we are going to focus on a very, very specific point in this huge space. We are going to talk about relational model. That is, we model the data as a relation, as a set of record. Okay, and then we talk about essentially relational query languages, specifically how to write SQL queries, right? Which is essentially how to use set theory to actually manipulate kind of like different relations, right? Now we are talking, when we talk about database systems, we are talking about the most standard ones, right? To actually optimize them without the help of new hardware you are seeing today, okay? But this course is just hopefully the beginning of your journey, right? Not the end, right? So down the road, there's a whole bunch of other courses also offered by the system group about essentially going deeper into data management system, about how to handle a whole bunch of this. Okay. So yeah, so that's what we have today, right? So just to recap, right? We talk about the information of this course. We give you one example, hopefully to convince you that data is important, database is important. You should care about this course, right? And we talk about different properties that we want from a database management systems, right? We want data independence, right? So we want to be declarative, right? And we talk about 3 generations of database management system and what can they do, right? How does their different view on what data is have impact on whether you have a system that satisfies all those properties, okay? So that's all for today. On Friday, we are going to actually go deeper into relational models. We are going to actually define the formulae, and we are going to give you 2 different ways that you can query your data within the framework of relational models. So that's all for today. I will be here to answer your questions. Otherwise, I will see you guys on Friday. Yeah, thank you. Okay, so let me try to go through all the questions. There we go. Okay, so I mean, if you have a question, just speak up, right? So I'm trying to still go through all the messages in the chat window. But if you have a question in the meantime, just unmute yourself and you can just ask. Yeah, so we have a question whether you really need to understand all those IMS queries. Yeah, not really, right? So they are just for like as one example, right? So we will be focused on relational model in this course, right? So that is like what you need to know, right? So in the exam, right? So are we going to look at in-memory column-oriented databases? We are going to talk a little bit of those, but they are not the focus of this course. Yeah. Will there be suggested reading per lecture? Yes, so we'll put that on the website. What are the prerequisite in terms of languages? Yeah, not too much. We are going to teach you a new language, that is how to write SQL queries. Yeah, I mean, you are not going to write a Python script. You are not going to write C++ in this course. Yeah. It is really possible. Is it also possible to just read the book and understand the topic for exam? In principle, I would say yes, right? So, and if you have a good handle of the Stanford book, I don't see any problem that you would have in the exam, right? So the only potential problem that I would see is that the book has a lot of content, right? And we are going to focus on a subset of that, right? So, and you can think about the lecture as giving you the scope of what to focus on when you read a book, right? So, because reading that whole book is a lot of work, right? And hopefully all the lectures can actually help you with that. Right? Okay, so I think that's all the questions, right? So if you have like any other questions, just speak up, right? So yeah, otherwise I'll see you guys like on Friday.